So I think you guys not only using robot, maybe you have some customized gantry need to be modeled, right? So now I will tell how to really to do this gantry. Okay, and also we have some local process for you to make like a screwing. Okay, so if you doesn't know how to extract the component, you can use this. Okay, here's the modeling gantry. I think we can focus on the gantry first. Okay, so maybe I will just save this file. Okay, but actually, if you have your CAD file, you also need to select the gantry feature and extract component of it. Okay, this is the same concept. But because there's too many things remains, I think you can skip this. Okay, so if you already have this one, maybe you can just go back to this automatic assembly machine. Okay, this machine, right? Today we already extract a lot of things, right? We already extract the conveyor module, we extract the tool head, we extract these two components, right? So now we'll extract this gantry. Okay, it's right here. So you select the gantry, okay, right click, okay, and then extract component. Okay, so there will be a gantry right here. Okay, so if you are running your project and there's no gantry, you can also find it right here. Okay, here's a gantry. It's also okay. These two are the same. Okay, gantry. Okay, and next step. Okay, let's follow up with the step. Okay, you just select everything. Okay, and then just press extract link. Okay, actually this is the same way you are using with the air cylinder. Okay, so just select everything. Okay, and then right click. Okay, select this gantry. Right click, extract link. Okay, and then just press apply. So this one is the link base. Okay. Okay, link space means the non-moving part of this gantry. Okay. And next step. Okay, next step. I think we can just like selecting XYZ together, and also the gantry XYZ. Okay. Okay, you can see here is the moving part. On this X slider, right? So we'll just right click, okay, and then extract link. And here's the origin that I defined for this part. You can also define like here, or like someone will have will define here. It doesn't matter if it's user defined. Okay, user can define everywhere for the origin of this moving part. Okay, so just press apply. Okay, so in my opinion, you can set right here. Okay, press apply. So maybe this one will be link X. Okay, let me check about it. Yeah, XYZ, right? So this one is link X. Okay, so under link X, okay, maybe we'll just select YZ again. Okay, and then extract link again. Okay, so for selecting Y, okay, Y means that this moving part from here to here, right? So maybe we can select here, okay, for Y. It doesn't matter, okay, it doesn't matter. You don't need to be same with me, okay? So maybe here will be Y. Okay. So you can see X, right? Y. And now we also need the Z part, okay? So we just expanded Z, right? Right click, extract link, Okay, maybe I'll select here as a origin and press apply. Okay, so just right click, extract link, select origin, apply. Okay, so just do again, right click, extract link, select origin and press apply. Okay, so here will be link C. Okay, like this. Okay, base X, Y, Z. Okay, so now we'll skip the forehead first. Okay, we'll skip the forehead first. Okay. So just link X, Y, Z. Okay. So I will do it really fast again. Here's another way. Okay, if you doesn't do like this, you can also do it parallelly. Okay, I'll just first resume it. Z, Y, X. Okay, I just resume it. Okay, did it. So you can also do like this. Okay, so I can right click. If I doesn't select all of it, maybe you can just, if you already have very clear classification of each link, you can also do like this. Okay, each link, just press apply. Okay, and back to Gantry. Okay, you can also like X, right click, each link, select origin, apply. Okay, so this one is link base. Okay, this one is link X, right? Here will be link Y. Okay, maybe it will be right here. Okay, it's the moving part from the left to right. And also here will be link Z. So you can also make it parallelly, okay? But after that, you have to rebuild the structure, right? Because Y is on the X and Z is on the Y, right? So you have to organize the structure again, like this. So it's also fine, okay? Both way is able to use for classify and extract the corresponding link first. Okay, so the first thing, you just use extract link to define what is the moving part, what is the stationary part. Okay, this concept is just same with the air cylinder. But like this one is the XYZ table. So maybe on the X there will be Y, on the Y there will be Z, right? And on the base there will be XYZ. Okay, you have to be like for this kind of structure. Okay, so like that. Okay. Typically we need to also set the range and the direction of each link. Okay, so you can see for X, okay, the range is 500. Okay, so maybe you can also take a try. If you doesn't know what is the range of it, here's a feature. Okay, you can click measure right here. Okay, measure. So you can find here's the stopper, right? Maybe here's the stopper right here. Okay, here is also another stopper right here. So you can see the whole range is 640, and maybe you have to minus the sec of this mover, right? 640 minus right here, right? 75. Maybe I make it 80. So the maximum range will be 75, right? 640 minus 75. Okay. 640 minus 75 will be 565, will be the range of X. So you can use measure to find out the range, even if you don't have the spec of it. Okay, so you can use measure. But I think in this stage, I just make it 500, okay? So you can click on link X. So right here, okay, set the join type to slider. Okay, this is the same setting with air cylinder. Okay, side slider. Okay, and you can see here. Okay, here is the moving positive direction. Okay, and it is with Z, right? So if I make it like this, it will be wrong. So I have to choose object and find out the direction. Okay, this will be positive Z. So this will be the right direction, right? And then I just set the range. Okay, the max stop will be 500. Okay, I think that will be better, like this. Okay, so please remember to change the joint type, okay, and then find out what is the direction of your origin, and make the reference right. Okay, and then set the range will be 500. And also, please remember to add the motor of it. So these two you have to enable. Okay, enable position sensor, and also enable the linear actuator. Okay, and also I will do for Y. So Y is the same way. Okay, so now actually the Y is also 500. Okay, the range is the same. So I'll do it again. Okay, joint type, change to slider. Okay, you can see now the direction is also Z, right? The positive direction will be Z. Okay, so maybe I'll make it Z. Okay, so that, and then we can just take a try. Okay, now the direction is right. And then we just set the next stop to 500. Okay, and throw it again, like this. And just enable the position sensor and the linear actuator. Okay, like this. Okay, so the XY will be set. Just change the joint type, set the axis reference to object, check out the origin directions, okay, and then just set the max stop of it. Okay. So we can also check what is the Z range. Okay. Yeah, I can see now we don't know what is the Z range. So maybe we can measure it again. Okay. So we can just measure. Okay. Maybe here is the 0 point. So from here, right, to here. Okay, we just measured the gap right here. Maybe will be 120. Okay, 125. Okay, dot 9. So maybe I can make it 120. It's a Z range. Okay. So also I just set the joint type slider. Okay, and check out. You can see now the positive direction maybe will be minus Z. Right, because the blue arrow is means Z, and it's the positive way is the negative direction of Z. So minus Z. Okay, and check. Yeah, that's right. Okay, and then I just changed the max stop to 120. Okay, and enable the position sensor and linear actuator. So now you are ready to go. Okay, like this. So you got X. Okay. So let's take a try. Okay, X will be like this. Okay, from 0 to 500 like this. Okay, Y. Okay, from 0 to 500 will be moving like this, and Z. Okay, from 0 to 500 will move like this. Okay. Actually, like the tool head, you can also do it like this. Tool head, right? You just insert the component, set a side interface so that the tool head will follow with the Z movement. Okay, but we can skip it right now. At this section, we just focus on how to build the XYZ module. So we already repeat the step and create each link and the joint type, and the joint setting of each link. Okay, so next step, okay, maybe we'll have to add behavior for it. Okay, so how can we add behavior? Is right here, okay. Right here, okay, we have to right click on here, right click, okay, and robotics, okay, create delta motion. Okay, delta motion is like a motion control card in DIATwin. So you will select delta motion. Okay, so actually like servo controller or another like robot controller is also fine. Okay, but it's just the difference is the controller type or the controller design of it is different. We recommend you to use real-time motion will be better. Okay, so if you have an actual motion control card, actually the algorithm is same with the actual real-time motion control card. Okay, so after select the real-time motion, right here will be settings. You just select X, Y, Z, and then press down. Okay, right click, create real-time motion. Okay, it's right here, robotics. Okay, real-time motion. Okay, in the real-time motion, go to settings and select X, Y, Z, and then press down. Okay, and next step, right click again, robotics, create the executor. Okay, the executor means there will be a top controller, right, for our local. You can see if you doesn't have the executor, go to program, you can see there's nothing. Okay, but if we create the executor for this component Gantry, you can see I create the executor, right? And then please remember here, okay, to select the controller as real-time motion. Okay, so if you select here the real-time motion and then go to program, you can see here will be a Gantry for you to use. Okay, the Gantry program. So please remember to select the controller right here. Okay, real-time motion. This is the same concept like today's morning lecture. I just set some device or link under the behavior. Okay. So next step, maybe if we need it to control with some emitter or receiver to the master, we have to create it, right? Because also like here, if we find a robot, right, you got like 5 emitter and 5 receiver. So when we go back to check in the IOs of the robot, you can see here will be 5 emitter and 5 receiver. Okay. So also in this Gantry, we will define it as an active, like a small top controller with assets. So we also need to create emitter and receiver. So please help me to click on, maybe here is also fine. Okay, right click, add device. So we can add emitter, and maybe right here, okay, you can select the quantity right here, maybe also 5, okay? And you can also change the name right here. Maybe you can say like R0. It's like this, R0 and make it 5. And then, so when you press apply, you can create 5 emitter at the same time. Okay, I will do it again. Okay, so maybe I will try for receiver. So that will be E, not R. Okay. The name rule is just depend on you. Okay, it doesn't matter. So add device. Okay, emitter. Okay, maybe it will be E0 quantity 5. Okay, and then press apply. And try again. Add device, receiver. So right here you can change the quantity. Maybe R0. Okay, apply. So you can see there will be 5 emitter and 5 receiver. So when you go back to our program, you can see signal. Here will be a Gantry for you. And here, for the Gantry, there will already be 5 emitter and receiver for you to use. And you can also change the port definition. It doesn't matter. You have to make sure when you need to control the Gantry IOs. Okay, so here's the Gantry, right? When you want to set or wait for the Gantry IOs, then you have to focus on what is this IO linked to what component, right? So I can also like using the Gantry to control the conveyor, not using the PLC. It doesn't matter. Just depend on what you design right here. Okay, so next, we already defined 5 emitter and receiver. If you click on the executor, there will be some emitter and receiver right here for you. Like yesterday, we had 2 small sub controller and 1 top controller, right? One we call it master controller. So the master controller will be built like this. Okay, it's also the same. Like here, if we check out with the PLC design, like here, okay, maybe we can check with the PLC AS332, right? Actually, it's the same. You can see here's the executor, and we just add a empty servo controller. You can see in the executor, there will be a lot of emitters and receiver. It's under it right here. Okay, so actually, it's just designed for top controller like this way. So Gantry is also the same. We just add a lot of emitter receivers, and you just need to create the executor, and also need to create some robotics behavior for it. Even it's empty is also fine to create your built-in controller. Okay, next thing is slot. Okay, but for the base, I think you already know how to build the slot to the table. Maybe we can just take another try. We are trying to slot the tool head on the Z-axis, right? So how can we do that? Okay, first thing, okay, in the link Z, okay, please remember under link Z, it's the parent, right? So we have to create a parent slot interface. So we can right click, create slot interface. Okay, and maybe we can just select a screw hole right here. It doesn't matter, okay, if we select here, everywhere it doesn't matter. Just select the place you can remember. Okay, maybe I will select here as an assembly point. Okay, and it is recommend you if you just creating the slot interface. Okay, you can first switch to Word. Okay, so when you create a slot interface, like this. Okay, you can make it 0. Okay. So it will be more easy because slot interface is just related with the XYZ direction. So you have to make sure that XYZ, the parent and the child XYZ are same with the same orientation. So it is recommend you to just set everything 0. Okay, and then press down. So now we already have a parent interface. Okay, so when you edit interface here, we cannot change the hierarchy because under the link you can only build parent. Okay, so back to our component. Okay, you can double click on this tool head, right? And you will find out the screwdriver module is right here. Okay, and also maybe you can also select like the camera right here. Okay, so you have to multiple select. Okay, press Control, select the single electric screwdriver module, select the camera. Okay, select this one. Right click, eject component. So there will be a new module right here. Okay, maybe I'll make it like an electric screwdriver module. Right. Okay. And next, we also need to create a slot interface for it, right? So right click at the first layer. Okay, first layer. Right click, create slot interface. You have to select the set point with the Z, right? So just click on here. Okay, and also I will make the XY RX RY RZ 0. And then please remember to select the hierarchy as child hierarchy. Okay. So actually this way is same with the robot. Okay, but the robot we doesn't need to create a parent. Okay, but this one is because it is a customized module. So you need to create a parent and child yourself. So back to our layout. Okay, you can select slot, right? So you can see now you will have a slot interface for you to connect. So when you release your mouse, there will be a green icon, means the slot will be created. Okay. So after that, back to our program. Back to our modeling, right? So like if you want to moving link Y, you can see now the component will move with the axis. Okay, like this. Okay, this is the same concept compared with the robot tool. Okay, maybe we can also make a small program because I think we have great process today. Okay. So for the tool head, right? We also need to create. Let's take a try. Okay, back to our program. Okay, go to our program. We can select the Gantry, right? And we can also turn on the drag mode. So you can see here will be a XYZ for you. Sometimes they will face some problem. Let me check about it. Position is out of reach. Okay, sometimes this kind of situation will happen. For me, if I want to fix this problem, you can fix the orientation of the origin. Okay, what I mean is I just change the origin definition, like setting X, I'll make the origin move. Okay, and make it 0. It doesn't matter because when I change the origin definition, if I control the thing X, it still work. Okay, because here we will also change by automatically. Okay, so I just set the origin again, make it 0, and also Z. Okay, origin, move, make it 0. And then back to our executor, XYZ. Okay, we'll try again. Okay, so you can see now it works. So we can draw this dragon like the robot. Okay. We can also draw like this to move the gantry. Okay, so some and also if I select this one, it will help me to reset to the origin position. Okay, so the problem is maybe the controller need to define the orientation of it. So if you cannot work, if you cannot moving by using dragger, maybe you can click on this. Okay, link X, origin, move, and just go to word or go to parent. So it's also fine. Just reset RZ to 0. So that back to our program and turn on drag mode. So now you are able to control the gantry. Okay, you can also take some points for you, like this. Okay, P1, P2, P3. Like back to initial pose. So when you start simulation, you can also control the gantry right now. Okay, so let's take a try. Okay, we can do a MP process for like a screwing. Okay, so how do we build it to build? Okay, so go back to our modeling of this tool head. Okay, we also need to create another coffin container, right? So you have to select the tip, okay, of this screw head. It's right here. Okay, please help me to select the tip and then press down. Okay, create the coffin container and select the tip right here. So if you do it right, so go back to our program and jog. Okay, so now you can select the coffin container for it right here. Okay, gantry, right? Gantry, jog mode, TF. You can select the tool tip right now. So you can use the tool tip to control the gantry like this. And also you can see we also can use drag by snap, right? Here's a drag by snap. So like here you can teach the point for picking the screw right here. You can see here's a speeder. So you can also click right here Okay, so we'll help you to teach the picking point. So you don't need to teach point like this one. It takes too much time, right? You can also use drag my snap to find out the feature right here really fast. You can find out a feature right here. You can see here's a screw, right? So maybe this point will be the picking point, right? So we can also set another process. Okay, maybe I'll just delete it. Okay, so please help me to go back to modeling. Okay, in the screw module, we have to add another tool container, select the point, okay, select the endpoint to the tool tip of it. Okay, I'll do it again. Right click, create tool container. Okay, select. You can select the edge and it will help you to find the center like this. Okay, and press down. So back to our program in the Gantry and turn on the drag mode. So the tool frame setting, you can find the tool frame container you created. Okay, so now you can just build the process again, like here. Okay, maybe here's also another ready point. Okay, this is P1. Okay, and then here, right, P2, and here, okay, maybe P3. Okay, so we just do an empty picking process like this. Okay, so there will be more real. So like you also want to take like a screwing process, it's also fine, right? You just need to stay up here using our capture function to teach the point right here. Okay, actually it's the same. Okay, maybe I can do a small example for it. Okay, so I'll use motion capture again. Okay, if you do some modeling work, it is recommend you to set the capture again. Okay, do not use the old one, because it will also help you to resume your modeling process. Okay, so I just record one point. Okay, maybe come here and wait for the top cover assemble. Okay, and pause, right? And do another capture. This will be position 4 and reset, right? So when I switch to position 4, here is the point that I want to do screw fastening, right? So after picking, I can also like go back to drag mode. Okay, select this point. Okay, maybe this point, right? Then here's the ready point. Then here's the screwing point. Here's the ready point, like this. It's also maybe right here. Okay, I can select here. Ready point. Okay, screwing point. Ready point. Okay, so go back to our initial pose. And maybe I have to take some delay for it. So I can add, maybe I can add some, this one is peak, right? Okay, peak. And maybe wait for 5 seconds. Okay, it's enough. Okay. So, okay, peak screw. And then screw point 1, right? Screw 1. And next, maybe I can just copy it again. So you pick again, right? Pick screw. P1 to P3 is picking. Okay, pick screw again. And maybe we don't need to wait for delay, right? And here will be screw 2. Okay, and reset. And also we have to reset the capture. Okay, so now we can start simulation. Okay, just go to pick. And now it's waiting for 5 more seconds. So press. You can see now it's screwing 1. And pick again. It's screwing 2. Okay, you can see now it is taking too fast. Okay, so maybe you have to delay a little for the PLC. Maybe 7. Okay, try again. So I think you can just build a process, your REST process yourself, like this. You already know how to do pick and place, so I think you also know how to do the the pick and place, and also the point teaching of this gantry. Actually, this is the same way with you are using the robot. If you need some reference, here's the point. Okay, you can also build like a subprogram, right? Like sequence, maybe you can just make it pick, right? So I can just reuse the P1 to P3 as a subprogram. So draw back to our main program, and you can see here we're using pick. So we don't need this one, right? P1 to P3. Actually, they are the same, so we can use the subprogram. Okay, and here will be pick again. So the result will be the same, but the code will be more easier for you to read. Okay, so let's try this, and this will be today's process. So let's try if you are able to build this kind of gantry and process yourself. And also, like yesterday's training, we already have a master controller to handle it, right? So maybe you can use gantry as a master controller to handle it with the robot and the conveyor. Or maybe you can just add another master controller. So there will be one master and 3 sub controller to make a handshaking. Yeah, it doesn't matter. Just defined by what you want to design the process. Okay, I'll make a quick rewind of today's lecture. Okay. Yeah, today we did learn a lot of modeling technique. Yeah, and because yesterday we already build your local yourself, and I think after today's training, you already know how to build a single component yourself, and follow up with yesterday's process, so you can now build your own project yourself. Okay, so back to our workflow. Okay, first you have to import the CAD, right? So our CAD file is like this one. Okay, it's an automatic assembly machine. So you need to eject component to make the components separately. Okay, because each component maybe there will be that for some components row they may have the top controller, they may have the conveyor, they may have the gripper. So we have to make it separately because they are not the same part. Okay. So we'll do next we'll do the yellow part, right? For some model, we'll do extract link, like gantry, like air cylinder. We'll use extract link to separate the moving part and the stationary part. And also, today we also built like a air cylinder. Okay, we built a conveyor, we built an obstacle sensor. Okay, maybe we have to add device or use extract device to point out the device point, and also what the kind of device you want to use in DIATwin. And also for link or for device, we will add behavior for you to take the relationship between the device and the emitter and receiver. And if some kind of device needs to have relationship for detecting something or for physics, you have to add bounding box. Okay, so here's the conveyor, right? So the conveyor, okay, here's the structure. You have to make sure that X direction is the conveyor direction. Okay, and you will use the track device. Okay, track. Okay, you have to use track device. You have to use receiver. You have to use conveyor behavior for conveyor settings. Okay, and here it's optional. Okay, you can also create some interface to combine to fix your conveyor on the frame. Okay, but I think this is optional. Okay, and here also, if you want conveyor to convey your product, please make sure to to enable the physics and also create the bounding box so that you can make sure your product will stay on the conveyor belt. If it doesn't have the bounding box, okay, so that it will fall on the floor. Okay, you can see here's the bounding box. Okay, please make sure you build the bounding box. Okay, and then here's the limited feature. So if you want it has a limited feature, you can go to track and select the feature and recompute. Okay. And next one, we build a sensor, right? And for sensor, typically we can use add device. Okay, so here's the add device. Like if you want to build, here's another sensor. Okay, if I want to build this sensor, okay, it's under conveyor. We can also like right click, add device. Okay, and select the sensor. Okay, and select the detection feature. Okay, and it will be X direction. And press apply. So there will be another sensor for you. You can see here's the detection line right here. Okay, and then you have to set the emitter, and also we use the optical sensor behavior. Okay, so also just remember the X direction is a sensing direction. And also right in the behavior, you can set the detection range. Okay, for air cylinder is also, you have to make sure there will be a base link and a moving link for you. Okay, so after the link is built, okay, you will create a slider right here. Here's a slider, okay, right here. So this is the same way with Gantry, right? You just build a slider, define the direction, okay, enable the position sensor and the actuator. Okay, like this. So after you just create a moving link, you also need to set the behavior. Okay, we use the air cylinder behavior, and also we add a receiver for it to build the air cylinder behavior. Okay. And next, we have to remember for the product. Okay, if you want your product be free in the space, it means what is free space? Okay, if your product physics are not turning on, it will be fixed in a space. So now you will not move, right? If you enable the component physics like this, so now you are just about to convey. Okay, so for product, mostly you have to enable the component physics. And mostly you have to add a bounding box so that your product will not penetrate on the conveyor or falling on the floor. Okay, here's another product, right? For the top cover is also, you have to extract component and add the bounding box. But the difference is because this top cover needs to be picked by the gripper. So we have to add another connector. It is passive connector for picking. And please remember to enable the physics and the parent link physics need to be true. Okay, here's also the gripper. Okay, for the gripper, we have to add connector for it. Okay, so actually this link, base link is not necessary. Okay, but we have to make sure we create a connector. Okay, and also the receiver for it controlling the connector. And here's the direction you need to check it out. You can see if we use preference view for the connector X6, okay, it's right here. Okay, the X direction is the force direction. So for the tool, the connector X will be downward. For the component, okay, the connector X direction will be upward. This will be a pair, okay? And one is passive, one is active. Okay, so this, please remember when you just building the vacuum gripper. Okay, and also, if the gripper needs to be follow with the robot motion, you have to build a star interface. So we got two star interface, right? One is the tool will follow the robot, and here also the tool will follow the gantry. We have to build the star interface right here. Okay, and also if you want the robot controller can find out the endpoint, you will have to build a torrent container, or also you can build some torrent. Okay, if you build the torrents, so under the drop-in mode, you can find here will be a container or frame for you to select. So you can use your endpoint to teach the robot. Also right here, right? For the Gantry, if you select the right torrent, okay, you are about to teach by using JustMySnap. Okay, so when you're using JustMySnap, please remember, often we won't use the set orientation feature. Okay, and finally, there's some local program logic, but we already showed yesterday, right? So we just focus on the last one. Okay, it's Gantry. So Gantry, we just iterate link, right? First, iterate the all component as a Gantry module, and then we iterate XYZ link. Okay, also set the joint property of XYZ. Maybe you have to set it as a slider, or like if you have a rotation stage, you can set the joint type as a hinge. Okay, let's take an example, like this one. But if the Z, or maybe I'll make it Y. The Y is hinge. So when we rotate it, we'll make it like this. Okay. So you can also set the joint type as a hinge. Okay, and after we just extract the link and set the joint property, we will add the behavior. So we add two behavior. One is delta motion, another is executor. So we just set the corresponding link under the delta motion. We'll set the delta motion under the executor. Okay, so also the executor means the top controller in our local. So we need executor. So here will be something for you to select. So if we build the executor, and we also can build some IOs for you, like emitter and receiver. So if you want like use a signal and make like a PLC need to be communicate with our Gantry. Like here you can see here's Gantry, here's PLC. So maybe you can also make a cross right here, so that now the Gantry are able to communicate with PLC. So handshaking, like waiting process down, waiting something else, and then I can start my process, finish my process, and I can get the return value back by using the cross right here. Okay, and also sign effects I already mentioned. Okay, so I think that's all for today's lecture. Okay, thank you everyone.